All right, and here we are right now with GraphQL. So instead of making a quick recap of what I have learned so far with GraphQL about what is GraphQL, what is the beauty of using that, how can we use GraphQL, what are the challenges that GraphQL solves, such as underfetching, overfetching. It also speed up the development process. That's part of the advantage of using that. And it provides schema and types. The disadvantage is that it's not a RESTful architecture, so you have a learning curve. Also, catching is something difficult in contrast with RESTful catching method that already works. And uh, this flexibility that this GraphQL, this new way of building front-end and back-end APIs and how they interact each other, uh, this flexibility comes with a price, adds complexity. And also see how can I start to using GraphQL specifically by using a graphical, this built-in front-end tool. I mean this built-in uh, this browser built-in tool to test your GraphQL query against a GraphQL server. Uh, I also started to see where is the specification, who made that, Facebook in 2012. Uh, what are the frameworks that use this GraphQL, such as Relay, for example, of this React for the React framework, and more high-end products such as Apollo, where you have is the uh, so Apollo allows you to build front-end and back-end GraphQL applications. So before dive deep into that, I saw how can we create a GraphQL server from the scratch using Express and a GraphQL Express middleware. Uh, See how are the main topics, especially when you define a type system that is used to describe the GraphQL capability, and also test that endpoint using tools like Postman or Insomnia to see that what happened behind the scenes, to know how the mechanism of how GraphQL works and how to test that without relying graphical. And then the finding is a more realistic projects, such as a e-commerce, and see that nested objects are very common in any e-commerce application or any application with some technical depth. So, which makes GraphQL a very good candidate for that. So, since querying uh, data is actually pretty straightforward, it's very easy to do. Uh, with GraphQL, with GraphQL, our API is organized in types and fields rather than endpoints, such as in RESTful architecture. So querying multiple collections endpoints to combine data in the front end is unnecessary in GraphQL. And again, this is part of the main issue that it solves, the underfetching and overfetching. So underfetching is that we lose time making additional unnecessary requests to querying multiple collections and then compose that on the front end, and that's underfetching. And overfetching is the server sends unnecessary additional data uh, for a particular endpoint. So we have to filter out the data and show only what is relevant to the user. Okay, so since I create is a e-commerce application, a more realistic GraphQL project, I also look at the GraphQL tools that we need for that, such as graph like GraphQL tools from the Dev Guild here. Yes, the guild here. A set of utilities for faster development of GraphQL schema. Okay, and uh, because once I define is the type system, okay, that is used to describe the capability of this GraphQL server, and GraphQL use that to verify if a request operation is valid to determine the type of the response result and determine if the input value of a variable is valid at request time. So looking at this, especially the code here, okay, in creating this application, uh, you can easily, or I ask myself is how can we break or type systems into multiple files? How can we organize our server per functionality and organize our server in a way that when we need to add more complex data to fetch our data, makes our life much more easy to maintain, right? Again, all of these questions can be under the umbrella term scalability. And because first I focus is on schema and how can we organize our application or modularize our GraphQL server, the schema GraphQL server, I rely on packages such as low file that allows you to keep look at the project folder structure. Uh, those files that end with GraphQL, which is a way how you break down your type system into multiple files and help you to organize your server per features. You have orders, you have product here, okay? And I also look at the graph, the GraphQL tool such as makes executable function where that allows you to import all of these types or this schema files and compose that into one file or into a giant stream here as a type definition, right? So this approach is good for when you have a type definition well defined for each one of those schema, and uh, they that they're not they don't have any name conflict. Okay, so uh, as we move on creating uh, or GraphQL in a modularized way for schema, then I look at another component important in GraphQL servers, such as resolvers. And to answer the questions that it relies on how do we query data. So resolvers are functions that determine the value of a property. When a query that GraphQL guarantees that is valid happen. So what happened here is that when I look at the graphical tool, so when you define is the field of that query, the server call that proper resolver and provide the value of that field. So once all of the resolver has found and called, so the server wrap up and send that data to the client. And because I saw how can we do that uh, with the resolvers, then I asked each. So the next natural question was, okay, so how can we modularize our GraphQL server uh, with resolvers? Again, relying on a package such as GraphQL tools, they allow us is to load all of the file resolvers here in the resolvers and look up the anatomy of the resolver as well, which is here we're exporting is this as a common GS model and look at their proper arguments, right? So all resolver have four so far has four arguments. So the first is that start with the root value that we pass through the GraphQL server middleware. Yes, of course, it's not here, but it's a root value that we pass through a GraphQL middleware. Okay. Uh, the other is the argument, uh, and this is used when we have parameterized queries and we have context to share data across different uh, resolvers. So, for example, when we pass authentication data about which user login for all resolvers, and you got the info. So, it contains some information about the state of the operation. So, I easily saw that the beauty of the resolver is that allow us to perform API calls, right? So by modularizing our GraphQL server, specifically the resolvers, uh, I easily create this structure, folder structure, where we have is the schema, the resolvers, and the data layer. So when I go here to the products, okay, I define is a parameterized query here by actually passing is the mean as float. You require this argument, the same for max, and this will return a list of products. So this is to simplify our life without having to check if the values that we're receiving are undefined. And also I define is another query, a parameterized query with an ID. Okay, makes sense. So by defining a query here, okay, at the entry point of GraphQL server, then I look at the resolver again, which determines the value of a property, and that allows us is to perform asynchronous API calls or API calls. So here for demo purpose, I set that with promise and to return that product. Again, here by calling is the data layer, and we are is just returning is this built-in object. Okay, so separation of concern is something crucial in any software development, and doing this at the data layer allow us is to modularize our application, aka make it more scalable, uh, and uh, in our case is this is the data layer access, okay, the the product model, the data layer access. That export is this data access function where we perform is this asynchronous operation. Right now, we're just only is doing that. This we're working with this built-in data for demo purpose. Okay, and uh, we adding this parameterized query. Okay, to see how can we create that entire process, the know-how to use queries or resolvers, parameterized resolvers, and here we are after implementing is the query problem by ID. Okay, now looking at the mutation. So yeah, I'm going just to read this out loud. Again, the whole idea of this is to create this narrative. And the importance of storytelling here is not only to sell, okay, but it's because you understand the reason of why you're learning all of this and be able to transmit that knowledge. And ultimately, well, if you want to capitalize that, do that. Okay, so we have here mutations in action. Believe it or not, GraphQL is not only for fetching data from the server. Believe it or not, this is using is this storytelling process. So believe it or not, GraphQL is not only for fetching data from the server. We also need to update existing data in our GraphQL. Okay. We also need to update existing data in our GraphQL. We need to create a new data. Okay, so exactly. So believe it or not, GraphQL is not only for fetching data from the server. We also need to update existing data in our GraphQL. We need to create new data and delete data that is not useful. So what's the GraphQL way of doing all of this? The creation and the deletion, and also the updating. So far, we have used query, the word query, to fetch data from our server. So when I run here the npm run npm start, that's right, because we don't have here is the current version of this, which is 14. No, version 14. That's right. And you might wonder why version 14. Newer version Node break the Express GraphQL middleware. And again, the whole purpose of this is just for demo. Uh, and to see how at least this is, and to understand is the pattern, the core concept, the basic building block, so you can then replicate that to other frameworks. Okay, now I can hit npm start on the terminal. That's right. We navigate to local host with GraphQL and the GraphQL path. All right. So yeah, by default, we are here is just querying data. We're just querying data. Okay, which is the behavior by default. Okay. So to fetch data from our server, that's the most basic operation that GraphQL support with API, getting existing data and reading it, it is probably the most common thing that you do. Yeah. Uh, so getting existing data and reading it is probably the most common thing you will do with an API. Getting existing data and reading it. So that's why GraphQL focus on doing queries really, really well. Okay? So getting data and reading it is probably the most common thing that you'll do with an API. Okay, so that's why GraphQL focuses on doing queries really well. So that's one of the reasons why you don't need to define query like that, because GraphQL assume, okay, that the most common operations you do in an API is getting data and reading it. Okay, getting data and reading it. So example of that is like orders. So you're getting data and reading it. You're getting it's just a single product. Okay, so, or you get all the data, getting data, okay, getting a list of data, getting data, or reading it by meaning is just one element, which is another way of getting data as well. Uh, but yeah, so that's why GraphQL focus on doing queries really well. But any real life backend applications need to support all of our crew operation: create, update, delete, because we already know how to read that. And to do all of these things in our backend, we use something called mutations. So mutations are the way of in GraphQL of you implementing crew operation, specifically create, update, and delete. And the crew is an acronym when you interact with a backend application to create, read, update, and delete server or delete data. Okay. So these operations are the two main type of operations that GraphQL servers support. Important note here. These operations, queries, and mutations are the two main type of operations that GraphQL servers support. So how do we make mutation? Okay, so here we are. Right. Okay, here we are. But now go to GraphQL. Yeah, then here we are. Let me close this. Nope, not at all. Take care, bye bye. Okay. I can listen to you.
Add reviews to any
Okay.
scene are the two
No.
main types of operations that GraphQL servers support. So let's get on with it then. How do we make mutations? Right now, none of our products have any reviews associated with them. That's why the value of our reviews field is null. Let's find out how we would let our users add reviews to any product. As you know, when we're getting data from our GraphQL server, we use what's called a query. We've seen that the word query is implied when we don't include the type of the operation. Now, if we're making changes on the server, we make this explicit by always typing the mutation keyword followed by some object. So I'll clear this left-hand panel here, just leaving the mutation part. But we're going to see that mutations are very, very similar to queries. Instead of the names of queries, like orders or products by price, we include the name of the mutation that we're making. To add a new product review, we'll name our mutation add new, name of the mutation that we're making. To add a new
Oh, right. The quality.
product review, we'll name our mutation add new product review, keeping things simple. Now, just like with queries, we can pass in arguments into our mutation. But unlike queries, the arguments in our mutation contain all the data that we're saving on the server. For reviews, the data we need to capture is a required rating, that's an integer, as well as an optional comment. But also, we need to associate a review with some product, most likely using the product's ID. Those fields correspond to the arguments we pass to our add new product review mutation. Maybe we're adding a review for our red shoe, which had an ID of red shoe. So we would pass that ID as an argument, just like with our queries. ID for the product that we're reviewing is red shoe. What about the contents of our review? We pass that in next. We'll rate these red shoes a 5 out of 5, and our comment will be that they're really great for coding. All right. Now, our mutations, just like our queries, can return some data corresponding to the mutation that we made. For example, maybe the server is generating a unique ID for our review that we don't already have access to on the front end. We could get that just like we do with queries, adding these curly braces and putting in the names of the fields we're interested in from the response. What we're essentially doing here is making a change on the server and getting the newly updated data back all in one mutation. This is especially useful if we're updating parts of an object that already exists and we want to get the final state of that object after our changes. We'll keep things simple and just return back the rating and comment for the review that was just created. To be absolutely sure that everything is working, we can get back the rating we just put in. And there we have it. Our first mutation, nearly identical to a query, with the exception that we use this mutation keyword, and our mutation is changing some data in our server. Let's keep things short and implement this mutation in the next video. We'll see that mutations are very similar to queries under the hood. The key thing is that
Let me go to this. Go to mutation. What the hell? Mutation here. Mutation here. Mutations are similar. Okay.
We'll see that mutations are very similar to
Mutations are very similar to
queries under the hood.
Under the hood.
The key thing is that we use the mutation keyword to let us know.
Okay. The key thing is that we use mutation. Okay. Keyword
That we're about to make some changes.
That we are about to make some changes.
And not just fetch some data. The word mutation
And not to just fetch some data.
comes from mutate,
Oh, well, exactly. Mutation comes from mutate,
which just means to change. All right, let's make some changes to our GraphQL backend. I'll see you in the next one. Welcome back. How do mutations work on the server side? In this video, we'll implement two mutations. First, the
Okay. Then we got implementing on the server side. Implementing mutations on the server. That's right. Implementing mutations.
ability to add new products to our product model. And building from there, we'll add the ability for users to add new product reviews.
Exactly. From the data layer, we're going to add the ability.
Sounds fun? Let's do it. Where do we start? With GraphQL, it's always by looking at the schema. Here in our products.graphql file, right below our queries, we'll add another root level type, which will hold all of our mutations. Our query type includes all operations that just read data, while anything like adding a new product or a new product review goes in the mutation type. We'll start with add new product, which will accept some arguments that capture the data we need to create a new product object. Let's grab those fields. We'll have one argument that takes in the ID, which is of type ID and is required. We have a description, that's a string and also required for every product. Next, we have the reviews, but it doesn't really make sense for a product to be created with some reviews already attached to it. The reviews are added by users later on. So luckily, our reviews field is optional, and we can move on to the price, adding that as the final argument. Price is a float that is also required. Now, as with any query, we can set a return type for this mutation. And we'll say that when we add a new product, we get back that product that we just created. This is a fairly common pattern in APIs to make sure that the right data was saved. There's our mutation, so what comes next? We need to add a resolver for our new mutation. Because mutations are top-level operations, just like our queries, we add them not under the query object, but instead under the mutation object, which is also a map or an object that takes the name of our mutation, so add new product, and sets it to some resolver function. We'll use this anonymous function, and the arguments to our resolver are the exact same as with our queries. The first argument is this parent, which we won't use, so we're going to set that as underscore, following the same convention as before, but we will make heavy use of these args that were passed in, which contain our product data. What is the body of our resolver going to look like? We're going to make some function in our products model that will add a new product. And we're going to put all of the logic to create a new product and save it to our data model in this function to keep our resolvers as thin and small as possible. We want these resolvers to be independent of whichever model we choose to use, whatever database we're using, and any other implementation details. All we're going to do is pass in all of our args into this function. The arguments we need are args.id, args.description, and args.price. This function will return back the product that was added, so we'll return that value back as the result from our resolver. That's the GraphQL part. But how does our model implement this add new product function? Let's take a look in products.model.js, where we'll add a function at the bottom that we'll call add new product. And this function will accept our three arguments: ID, description, and price. We'll create a new product in a constant, let's call it new product, and that's going to be an object which contains our ID, the price, the description, and also we should set our reviews field to either null or better yet, an empty array to show that this fresh product has no reviews. Now, to be consistent with our pre-populated products array here, let's add an empty reviews array for each of our test products here. So reviews is an empty array, and for blue jeans, we also have reviews being empty. Back in our model function here, we'll take this new product and push it to our products database, or in our case, the in-memory list of products. We'll take the products array and push the new product we just created. Our mutation returns back the product that was just created, so we'll return back this new product, which will come back from our model function here, back into the resolver, and finally be returned back to the client that added the product. Last but not least, we need to export our add new product function. Let's test our work. So we'll start up our GraphQL server. Here in Graphical, let's try adding a new product. Just like with queries, we can make multiple mutations all with one trip to the server. So above our add new product review mutation, we'll add a add new product mutation, where we create a product with an ID that's, say, orange jacket, and the description is going to match our ID. So description will be orange jacket, which is going to be a bit more expensive than our shoes. So we'll say the price is $70.55. And what we'll get back from this mutation is the ID of the product and any reviews, which we decided is going to be empty. Graphical is now going to try making two mutations, only one of which is implemented in our server. Let's see what happens. We're getting back a few different errors. Notice how helpful GraphQL's error mechanism is. It's returning back everything that's wrong in all of the operations that we're trying to make. So at the bottom of our errors here, we have a message that says, cannot query field add new product review, which makes sense because that mutation doesn't exist on the server. And it even suggests that we might have made a typo and instead meant to add a new product, which is a mutation that does exist. Okay, so this error is expected, but this first error, what's that all about? Field reviews of type review must have a selection of subfields. Of course, the reviews we're getting back from our new product is itself an object, which means that, as with any GraphQL query, we need to select which subfields we're interested in. Maybe it's just the rating of each review. It shouldn't really matter because our reviews will be empty. All right, let's see what comes back now. Just the one error that we expect because add new product review doesn't exist. So we can cut this for now and try making the single add new product mutation, which works. As expected, we're getting our new orange jacket with an empty reviews array. Things are working great. Let's add back this add new product review mutation, take a quick break, and come right back to add this second mutation to our server. I'll see you after the break.
Interesting. Okay, that's actually very interesting. Of mutation and how you can create a mutation for that. Okay, so since the two main type of operations in GraphQL are queries and mutations, so they organize this the resolvers that are responsible for uh, that are responsible for determining the value of the data of the property, and that's one of the two main components of GraphQL server, schema and resolvers, and the other is about operations, queries and mutations. Okay, so things are starting to make sense right now. Okay, much like the same as when we talk about crew operations in RESTful architecture, where the operations are now based on the HTTP verb. Okay, so you use the get verb for getting data, and you use also a server error code. You use the post for creating a new element. You use the update for update an existing element. You use the delete for doing that. And you also have the options and patch. So what it's doing here, GraphQL, is by abstracting is the underlying layer of how the communications work between the client and the server, how the HTTP communication works. Okay, this one way of communication is like a walkie-talkie communication or half duplex, when you have to wait for the other uh, to before talk. Okay? Mhm. Okay. Mhm. Okay. Interesting. Interesting. Very, very, very interesting. Okay. So mutations are very similar to query until in the hood. The key thing is that we use mutation keyword that we're about to make some change and not just to fetch some data. So when you want to make change or mutate the uh, the state of a document, you make a mutation. And in the crew operations is the create, update, and delete. When you define a query for that, is to fetch some data, is to read data. And that's one of the reasons why GraphQL is so focused, or why GraphQL is really good, is really, really good at uh, doing query, because getting existing data and reading it is probably the most common thing you will do. Yep, it's probably the most common thing you will do. Okay, interesting. Very, very interesting. Mhm. Mhm. Very, very interesting. Very, very, very interesting. Okay. Mm. So to wrap up, so to wrap this, to make a quick recap of mutation in action. So after I look at how can we define queries, how after I look at how can we create a type system, then how can we modularize our type system, uh, the schema and the resolvers, which are two main components in any GraphQL server. So schema allows you to describe its capability of the GraphQL server, whereas the resolver to determine is the value of a property when a valid GraphQL query is made. So uh, so I look at how can we modularize the application on a using for schemas and for resolvers, and then how can we get how can we define parameterized queries, or AKA filter out data, filtering uh, with queries. What is the GraphQL way of doing things? This mindset is something crucial. What is the blank way of doing things? And this is something that to me struck me the most, because when I started this area, okay, or this journey on how to interact with computers and how computer works, is because they have the language or the compiler, even the binary. They have a particular way of doing things. And anytime you saw any uh, applications or tool frameworks, language, compiler, so what is the way of blank doing things? So what is the Dino way of doing things, right? For example, what is the Node way of doing things? Dino way of doing things. And again, this is all about talking about the mechanism. What is the way of doing this mechanism? The know-how. Okay, okay. And well, so believe it or not, GraphQL is not only for fetching data, but also for updating existing data and deleting in a GraphQL. So what is the GraphQL way of doing that? So since we use underneath the hood query, and this is something that is implied here. So when you define a query, it implies GraphQL that you put is the query, okay, to fetch some data. And with APIs, getting existing data and reading it is probably the most common thing you will do. That's one of the reasons why GraphQL is really, really good querying data, on doing queries. That's why GraphQL focusing on doing queries really, really well. But in any real life applications, you also need to support the crew operations: create, update, and delete. So all of those operations are done using, yeah, all of those operations are done with something called mutations. And mutations on queries are the two main operations uh, that a GraphQL server supports. Okay. And then how do we make mutations? Okay. So mutations are very similar to query underneath the hood. The key thing is that we use mutation keyword when we want to make some change and not just fetch some data. Okay. 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 Interesting. Interesting. Very, very, very interesting. Uh, so with that, I'll see you in the next episode. Uh, Take care. Bye bye.